In this video series, I'm going to show the build of a universal coil winding machine. There are several videos on YouTube already that show the use of one to make radio coils. It's a handy tool when you like to restore or build your own tube radios. I'm going to be showing the build using a drill press, hand saws, grinders, sanders, and other basic hand tools. I use a machine lathe to make some of the parts. However, when I do that, I'll also explain how to make those parts or to get around making those parts for those of you who don't have a machine lathe. Let's get started. The materials for this project start with a block of cherry wood for the base. This piece of angle steel will be used for the frame parts. I also have some steel flat bar and some more steel flat bar, a round rod of brass, piece of 12L14 free machining steel, and some rod stock, also 12L14. In addition to all of that, I'll be using springs, screws, and other bits and bobs. This tool is my answer to not having a bandsaw. Maybe one day I'll have a bigger garage and be able to fit a bandsaw inside. I'm going to start by cutting the angle steel into 4 pieces. 2 5-inch pieces and 2 2-inch pieces. I marked the steel with 2 lines that are spaced 1/8 of an inch apart. That way I can shoot for the middle of the lines and then file or sand till I get to my tolerance. This isn't a high tolerance part. As you can see, the saw blade doesn't cut completely through because the stock is too big. That's one of the limitations of having such a small tool. However, it's easy enough to turn it around and cut it from the other side. I'm going to have to hold on to the far end of it so the large piece doesn't fall once the steel is completely cut through. As you can see, there's a little bit of a nib on the top. When I get my sander out to sand these edges flush, it should go away. However, this is just a structural piece and that part doesn't exactly matter. And there you have it. Those are the pieces that we'll be using for our frame. So this tool is essentially an angle grinder on a chop saw frame. It has a little clamp that allows us to make angle cuts with some degree of repeatability. It's nowhere nearly as precise as a machine tool, but for the amount of money I paid for it and also the small size, it works pretty well. Of course, you're going to want to use hearing and eye protection when you use that because you saw it kicked up a bunch of sparks and it's also very loud. Another good safety tip is not to talk to anybody on the internet about using such a tool because they'll all wonder why you're not using a bandsaw. Let's go on to the next step, which will be cutting the wood frame. The Craftsman bandsaw is a tool I've had in my collection for 10 years. Like every other tool in my workshop, it's small, so I don't have the ability to create large things with it. However, most of the things I create are small anyway, so that hasn't really held me back. What we're doing now is going to cut out the profile of the base for the coil winder. This little notch here provides us some clearance to turn the hand crank, but it's a 5x5 square of wood in whatever size you have. The plans call for 3/4 of an inch. You can make it out of a piece of 2x4 or more like 2x6 lumber if that's what you have on hand. You just need something sturdy to set the metal parts on. Now you notice I didn't use the guide. If I were using a table saw, I definitely would be using a guide. However, my preference for small pieces like this is to draw a line, cut right outside the line, and sand down to it. That way I get a smooth edge. Because even if I did run it on a table saw, I would still need to sand it anyway. Another tool I've had for 10 years is this Craftsman drill press. It's a benchtop drill press with a 1/2 horsepower motor. Some professional machinists would scoff at it because it's not a full-size machine capable of doing full-size work. I would say that I'm not a full-size machinist, I'm not a production engineer, I'm not even a machinist, I'm just some guy who bought a lathe. So, it does everything I need it to do. The only part I've had to replace on it is the spring that goes in here. That's the Coil return spring, and you can get them on various places online for about $10–15 when they break. It's broken twice, but that's the only thing that's broken on this machine. I would definitely recommend getting a Craftsman drill press if you can still find one. Something I did off camera was lay out the holes for all of these holes I'm going to drill in this angle stock. I didn't figure everyone wanted to watch me draw with purple marker and scribe with a scratcher. The holes here are going to be mounting holes, 5/32 of an inch, and that's where the wood screws will go through the angle. And these will be bearing holes. The plans on these call for 1/4 inch holes. However, I'm going to drill them out to 3/8 of an inch and insert a brass bushing which will be soldered in place. If you're not using a metal lathe, you may not have brass bushing, so you may just want to drill the 1/4 inch holes. Or you may want to drill a larger hole and glue in a piece of brass tubing or something else that works well for you. You don't need a machine lathe to make this project. These pieces here will face each other, something like this, and the bearing holes will face each other and the rods will run between them. In the very middle will sit a step counter which will be actuated every time the main crankshaft turns. These sit opposite each other. See, back piece and front piece. And this here will be cut away to match the cutaway in the wood. Front piece here. See the hole, it's right there. The back piece, the hole is right there. The hand crank will go through those holes. That moves the cam, which will move the wire shuttle back and forth. And it'll also move the friction drive, which will rub up against the friction plate and turn the coil shaft. Let's get started with the drilling. So I haven't bought any steel cutting oil, but on my last oil change for my car, I saved some of the spare oil from the car change. It works better than nothing. Again, I can feel people furiously typing comments about that, but it'll be okay. Put the safety key in the drill press. I'm going to install a 1/8 inch drill bit for my pilot holes. Alright, and let's get started. I keep clamps here. Something big like this piece would very likely get flung away by the drill press once it punched through and grabbed, especially on larger drill holes. So when I drill something like this, I clamp it in place, and that way it doesn't I don't have to worry about it flying off once the drill is complete. Yes, there are probably better tools for this too, but I have what I have and I'm using it. Alright, let's get drilling. Something you want to look for: long stringy chips. If you're running your drill too fast, especially with larger drills, you may get little slivers that are extremely hard to see but will show up very well when you walk through here barefoot. Another thing I don't really advise. I run a mag broom through my garage when I'm done working on metal, and the mag broom picks up most of the metal fragments. However, it doesn't pick up all the metal fragments, and then my feet typically pick up the rest. So best thing to do is not create little needle-like slivers, and you won't have to worry about stepping on needle-like slivers. Another thing is, 1/8 of an inch drill bit needs a lot more speed than, say, a 3/8 inch drill bit. Put these down here on the lower shelf so they get vacuumed away later. Now, even though I'm going to drill these to 5/32, I start with 1/8 of an inch. And as I open up the hole, it's less wear on my larger drill bits. Had that thing in my hand a minute ago. I swear. At least half the time I spend in my garage is spent looking for the tool I was holding 5 minutes ago. Okay, and I have one more hole to drill. Okay. This is a $1 ketchup bottle from Walmart. Okay. Now off camera, I'm going to get all of those 1/8 inch drill bits drilled, and then I will change to the larger drill bit. What I've done is drilled all the holes in these angle plates. The smaller holes are 5/32 of an inch. Those are going to pass wood screws, and those are the final size. The larger holes I stopped at 1/4 of an inch. The 1/4 inch holes can pass the rods, and if they do, you can be done right now. I'm going to drill them about a little larger so I can put brass bushings in there to better hold the shafts. But if you are not doing that, you don't have to. What I do need to do for these smaller holes is deburr them using a countersink bit. My countersink bit I use with a cordless drill and I removed the burrs from the holes. Now, it's a 90-degree countersink. If you don't have one of these, you can use a larger drill bit. Just run it in there a few times. Let it take off the rough edges at the end of the hole. Raises up a little bit of chips here, but it removes the rough edges and gives you a nice smooth edge of the hole, so it won't snag on the wood or make the piece sit unevenly. If you're machining things in a mill or a lathe, it's important that you knock those off. I've got a 9/32 inch drill bit in the drill press. For the larger bit sizes, I'm going to use this angle iron here, clamped to the rails with bolts. This should provide some solid bracing against twisting. If the drill twists the work out of my hands, then it will most likely come back and hit me, or at least cut my hands up. I use these to clamp the angle piece down using the slots. Bolts go in slots, slots go through table, tide goes in, tide goes out. I forget how that works. I've got the angle block bolted on the table. The nuts are snug. It doesn't move very much. It doesn't need to be a accurate fence for drilling the hole. It just needs something to hold the piece in case the drill bit decides to grab it and keep it from getting swung by the drill press. I could also clamp the thing directly to the table, but this fence will work fine. Got my oil. That drill bit went through very easily, but you saw how the fence moved. It moved, but it didn't be pushed completely out of the way, so it kind of works for what I needed. For some added insurance, I'll crank down the bolts a little bit. There, maybe that'll be a little better. Always works better if you remove the cap. These will be where the added rigidity of the angle plate will come in handy, because these are the ones that are going to be dangerous if the drill press decides to grab them. One thing you see about the oil is as it smokes off, it's also taking heat away from the metal. So in addition to lubricating the drill bit, it also acts as coolant. Again, there are better oils for this than what I'm using, but it's still working better than no oil whatsoever. There are certain metals, cast iron being one, that you don't want to use oil on. Cast iron has graphite in it, and you can drill it dry. Speaking of drilling it dry, I almost drilled that dry. Okay, I'll switch the drill press and I will be right back. With all the drilling and deburring done, the last thing I need to do for this is give everything a nice sanding. That'll get the fire scale off of the hot rolled steel and also make the edges of the wood look a little better. I'm going to finish the wood with some Watco teak oil, and I'm going to have to get some clear coat for the metal parts. The metal is going to need to be absolutely clean before I solder, so after I sand everything up, it's going to have to be washed off with some soap and water to get all the oil off of it. I cut the corner off of the one piece that's going to go in the front. The edge looks a little nasty because I did it with an angle grinder. I didn't get any footage of it, but it was definitely difficult to fixture. The sander will take care of all the deburring. After some sanding and otherwise polishing, I have my base pieces on the floor where I need them. Sufficiently shined up. I may get them with some green Scotch-Brite more, but the first thing I need to do is solder the bushings to the holes. So some of you might have noticed that I didn't use a reamer to ream out the holes. That's by design for now. I do want a little bit of clearance between the bushings and the holes. I can always turn the bushings to the size I need for the holes, but I do want some clearance there so the solder has somewhere to run. Now that the wood base is completely done though, I am going to put some finish on it. This T-coil should seal it a little bit. It's not as shiny as the Danish oil I'm used to using. However, it's a good way to protect it. I prefer penetrating oil finishes over film finishes such as polyurethane. Everyone has their own opinions on what's the best finish. I don't really care to hear them because I will finish them how I like. We reached a stopping point for now, and next I'll cut some bushings on the lathe to fill the larger holes, and then once I have those installed I can align all of the plates with some rods and screw them into the wooden base. Hopefully you learned something from this, and even if you didn't, maybe you enjoyed watching my first steps in building this machine. Hope to see you soon on my next video. Thanks and have a good one.